Here we're converting between compound units. So it says a cyclist rides her bike at the speed of 9 kilometers per hour. What is the speed in meters per second is the first question. And then how many meters will the cyclist travel in 2 seconds? Do not round your answers. So the first thing we want to do is figure out what we are working in, our units. We see that we have 9 kilometers per hour. So knee-jerk reaction, we want to create a fraction with this. 9 kilometers, and this is per 1 hour. So we have 2 units that we're working with. We created our fraction, and we want to know what the speed is in meters per second. So we're going from kilometers per hour and converting to meters per second. So we need to move from kilometers to meters and from hours to seconds. So the first thing I want to do is get rid of one unit. I'm gonna get rid of 1 unit at a time. I like to stay organized, be patient with it. So I'm gonna get rid of my first unit of measurement and convert it from kilometers to meters. So in order to do that, I know that if I have the same units on top and bottom of a fraction, they get canceled just like real numbers would. So I'm going to create my bridge here, and I'm going to put kilometers on bottom so that my kilometers are going to cancel. Well, I know that kilometers has a relationship with meters, kilo meaning 1,000. So when 1 kilometer, I have 1,000 meters. And I see here that as soon as I do one bridge, when I have multiple units, I want to cancel my units. And now I'm in meters per hour. Well, meters is what I want, so I'm going to go ahead and circle that. I no longer need to work to convert this unit of measurement, but now I can focus on the time. Meters per hour is not right, but meters is. We want meters per second. So now I need to work on converting hours to seconds. And of course, I'm going to have to pass through minutes. I don't know how many seconds are in an hour, but we're going to pass through minutes. So in order to cancel hours, I have hours as a unit on the bottom of a fraction, so I know it's going to need to go on top. So I put hours on top. I know that hours has a relationship with minutes. So in 1 hour, I have 60 minutes. And now I can cancel my units hours and hours. And now I'm in meters per minute. Not quite there, so we need to do one more conversion because we need to get to seconds. Minutes is on bottom. In order to cancel, we put it on top. And minutes has a relationship with seconds. In 1 minute, we have 60 seconds. And our minutes are going to cancel. So here finally we have meters per second. We can circle it. That's the unit we want it to be in. So we ended up in meters per second. And now we have a little bit of a conversion bridge, which is really just fractions. 9 over 1 times 1,000 over 1 times 1 over 60 times 1 over 60. And when we're multiplying fractions, we just multiply numerator to numerators and denominators to denominators. So we have 9 times 1,000, which is 9,000, times 1 times 1. So we're left with 9,000 on top. And then on bottom, we have 1 times 1 is 1, 1 times 60 is 60, and 60 times 60 is going to be 3,600. So let me just grab my calculator since it says that it doesn't want to round answers. And we will, let me put this on here, there we go. So we'll take 9,000 and divide it by 3,600. And that gives us 2.5. So we have 2.5, and remember our units, meters per second. So 2.5 meters per second is the equivalent of 9 kilometers per hour. Now it says, if he is moving 2.5 meters per second, how many meters will a cyclist travel in 2 seconds? Well, if he travels 2.5 in 1 second, we just need to multiply this number by 2. And when we multiply 2.5 by 2, we get a total of 5 meters in 2 seconds. So 5 meters in 2 seconds is, there are 2 answers. Our 2.5 meters per second is the equivalent, and he will travel 5 meters total in 2 seconds.